Hi, scholars. Happy Thursday. Today is Thursday, May 7th. I'm really excited that we are ready to move on to our next unit on multiplying and dividing fractions. This is because we had so many 100% or 80% on adding and subtracting fractions yesterday. Quick shout outs for yesterday's 100% club from UNC. We had Ajane, Dillery, Chris, Annalie, Kamaya, Temmit, Manuel, Andrew, Shania, and Anaya. That is a ton of 100%. Nice work, UNC. In SCU, we had Michelle, Jakira, Hoel, Danya, Alejandra, Corday, Amelia, Neve, and Aiden. Crushed it, SCU. And from Duke, we had Edwin, Larry, Tatiana, Camila, and Deame. Really nice work. Many scholars who aren't on this 100% club list were actually on the 80% club list. You scored 80% on yesterday's practice. A few of you needed just a little bit more help and got that this morning at reteach. So we are ready to move on to multiplying and dividing fractions. As a reminder, today is Thursday, which means you have today and you have tomorrow to finish spiral review number 3. This is just a list of scholars who have already completed spiral review 3. UNC, you are crushing it with the most scholars. Jaden, Tembi, Dillery, Ajane, Miguel Angel, Anthony, Manuel, Annalie, Lyric, Jasmine, Latasia, and Kamaya. You are already done with spiral review 3. Phew, nothing you need to worry about there. SCU, kind of a sad list. Only Danya, Ricardo, Corday, and Adam are done with that spiral review 3. And in Duke, we have Chris R., Chris C., Alberto, Yulady, Miguel, Deame, and Lovely, who are all finished with spiral review 3. If your name is not on this list, it means either you started it but you're not done yet, which is fine, or you haven't started it yet. If you haven't started it yet, you have today and you have tomorrow. Today and tomorrow, you will have a regular math lesson, so don't save it all until late tomorrow. This is worth quite a few points. Just because there's so many questions. So that's just my reminder. Huge shout out to all of these scholars for already getting your spiral review complete. Nice work. All right, and a quick look at our Kickboard points, our Vista virtual points, and then we'll dive into multiplying and dividing fractions. All right, it's becoming quite the exciting competition. Keep having our first place winner overtake our second place winner, overtake our first place winner, but looking great over here at Hadley with Emmanuel in the top. Amelia now joining our top 5. Huge shout out there. You can see scholars who are in our top 10 looking great. Scholars who are in our top 20, a lot of points. Remember, make sure you are coming to social lunch on Monday to claim your prizes. Last week, I think there was a 3rd grader who won the pizza lunch, but then he wasn't even there, so he didn't get to keep it. Bummer. You have so many points. Scholars like 10 Beat are getting at least 40 raffle tickets into that raffle. Make sure you are there to claim your prizes. So excited about seeing you guys on Monday. And over here at Maryvale, we have Madeline in the lead, Larry in a close second, followed by Edmund, Tatiana, and Yulady. So keep up the great work, Maryvale. Scholars who have points in the top 5, in the top 10, in the top 20. Lots of prizes coming your way as well. So lots of excitement there. Keep it up. Keep turning in your assignments, turning them in on time, showing that academic excellence so you can continue earning those points. All right, with that, we are moving on to multiplying fractions. We've done a lot of work with adding fractions. Today, we're going to be taking a look at 4 different word problems and think about all the different scenarios where we may need to actually multiply fractions. Then we'll talk about some different strategies we could use to multiply fractions, and then do a little bit of practice at the very end, and you will be done. So in our first scenario here, I'll just follow along as I'm reading the story. So Dillery loves fudge. And so for her birthday, she says, I would love it, Mom, if you would make me some fudge. So her mom makes 5 batches of fudge for her birthday. Now, each batch of fudge needs 1/3 of a cup of walnuts. So we need to figure out how many cups of walnuts does Dillery's mom need to make the 5 batches of fudge. Lots of different ways for solving this. I want you to take 2 minutes on your own to try this one, and then we'll take a look at some strategies. Go ahead. How many cups of walnuts does Dillary's mom need? You can start by asking yourself, will her mom need more or less than 5 cups of walnuts for the fudge? Go ahead and get to work. All right, take 20 more seconds. It's okay if you're not done. If you've already finished, you can even try a second strategy. How many cups of walnuts does Dillary's mom need? All right, let's take a look at what some scholars did to solve this problem. You have your scrap paper out, you have the strategy that you used, and then additionally, you can be writing down any other strategies that you didn't think of to use. So one thing we can always do is we can always draw a picture. So if I think about Dillary's mom making these 5 batches of fudge, making a model, especially with fractions, is always a great strategy, always something I want to have in my back pocket to use. So here's her 5 batches of fudge, and each batch of fudge just needs 1/3 of a cup of walnuts. So I'm going to show, there's batch 1, it's just using 1/3 of a cup. Batch 2, also using 1/3 of a cup. Batch 3 uses 1/3 of a cup. Batch 4 uses 1/3 of a cup. And batch 5 uses 1/3 of a cup. For every batch of fudge, only 1/3 of it, only 1/3 of a cup of walnuts goes in. And so now all I have left to do is count up how many third cups of walnuts that is. So 1/3, 2/3, 3/3, 4/3, 5/3. So her mom will need 5/3 cups of walnuts, which I know how to simplify into a mixed number, which would be 1 and 2/3 cups of walnuts. I can also see that in my picture because this 1/3, 2/3, 3/3, this makes up 3/3 or 1 whole, and then we're left with 2/3. So drawing a picture is always a great way to go. To get to my answer, she'll need 1 and 2/3 cups of walnuts. Another thing that we could have done is we could have used repeated addition. Her mom needs 1/3 cup of walnuts for every batch of fudge, and she's making 5 batches of fudge. So I could have added 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. Good thing we are so strong at adding fractions. I know when I'm adding fractions, I'm so lucky because my denominator is already the same. It's already a common denominator. So my denominator stays the same, and I just have to add my numerators. 1, 2, 3, 4, 5. And we get to an answer of 5/3. I can then reduce that. That's the same as 1 and 2/3 cups of walnuts. Now, another thing we can do that we're going to be practicing in this unit is we could have multiplied. If you did not have a multiplication equation written on your paper, now is the time to do it along with us. We showed how this would look with a picture or a model. We showed how it would look with repeated addition. I know that 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 is the same as just 5 times 1/3. And so now we remind ourselves, okay, well, how do we multiply fractions? Well, when we multiply fractions, it's a little different from adding them. In fact, Sometimes it's even easier because I don't need a common denominator. Instead, I just multiply my numerators and then I multiply my denominators. Now, when I have a whole number, 5, we know the denominator is actually just 1, right? Anytime we have a whole number, it's like that number over 1. And so now I can just multiply straight across. I can multiply my numerators. 5 times 1 is 5. And then I can multiply my denominators. 1 times 3 is 3. I did not need to find a common denominator. When we multiply fractions, we just multiply our numerators together, and then we multiply our denominators together. 5/3, which we now already know, is the same as 1 2/3. So Dillary's mom, for her 5 batches of fudge, she'll need 1 2/3 cups of walnuts. Yum, that fudge looks really delicious. All right, 3 different ways that we could solve this problem: by making a model, by using repeated addition, and then by multiplying fractions. Let's take a look at another one. All right, follow along with your eyes as I read this story to you. Anna Lee is playing Mario Kart with her sister. The race is 6 laps around the track. Each lap is 2 1/4 miles. How long is the entire race? So I'm visualizing Anna Lee. I'm picturing Anna Lee's probably winning the race. Anna Lee, I picture you're probably this Mario guy right here, beating everybody. And Anna Lee needs to go 6 times around the track. So 1, 2, 3, 4, 5, 6. 6 times all the way around the track. Now, every time she goes around the track, it's 2 1/4 mile long. And we want to figure out, well, if every time she's going around the track, it's 2 1/4 miles long, how long is the entire race? Go ahead, and I want you to try this one on your own. Think about what this problem is asking. You can write an equation to start you off if that helps. I know in our last problem, it was asking us 5 times 1/3 would equal the total number of walnuts. You can start with a number sentence to match the story if you would like. You could draw a model. You could use repeated addition. You could try multiplying fractions, however you want to try it. Go ahead, 2 minutes on the clock. Figure out how long is Anna Lee's race. You have about 30 more seconds to wrap up your work. It's okay if you're not done, but glad to see everyone off to a strong start with a number sentence that matches the story and attempting one of our strategies. All right, let's check in and see what we got. So as I think about what's going on in the story, if the race is 6 laps around the track and each lap is 2 1/4 miles, of course, we're multiplying. So I want to make sure that I have my equation written down. This is asking me to multiply 6 times 2 1/4. All right, let's take a look at some strategies that some of our classmates used. If you see a strategy that you used, that's great. Check to see that yours matches mine. If you see a strategy that you did not use, this is the time to write it down. It is so great to have just a collection of strategies that you're able to use for different problems. So one thing we could have done is we could have drawn a picture. And so as I think about what I would draw here, well, the race is 6 times around the track, and each time Annalie has to go 2 1/4 miles. So for every lap, she's going 1, 2, and 1/4 miles. This is how I would show it for one lap around. So then in her second lap, she would be going 2 1/4 miles. In her third lap, if you didn't already have a picture, you're adding it to your page now. You never know when you might want to come back and use a picture depending on the problem or the number type. So always great to just practice what this would look like to make a model. All right, so I've drawn out for the 6 laps, each one was 2 1/4 miles long. So now all we have to do is count. I'm gonna go ahead and count my whole numbers by 2. 2, 4, 6, 8, 10, 12. So that's 12 miles, and now I'm gonna count my fractions. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. All right, so 12 6/4. I don't want to leave it like that. I want to be just a little bit more precise by turning this into a mixed number instead of an improper fraction. I know 6/4 is the same as 1 2/4 because I have 1/4, 2/4, 3/4, 4/4. This would be a whole, and then I have 2/4 left over. So we have a total of 13 2/4, or we could say 13 1/2 miles. Phew, that's a lot. So Annalie has to beat her sister around 13 2/4 times if she wants to win the race. So one thing we could do is we could draw a picture. Drawing a model is always a great strategy if we're stuck, but it is a little bit more time consuming. It does take us a little bit longer. So let's take a look at some strategies that are just a little bit more efficient. Right along the lines of drawing out a model, we could have also used repeated addition. I know I can use repeated addition here because I have a whole number multiplied by this mixed number with a fraction here, and I can add 2 1/4 exactly 6 times. I know how to do it. So let's try it with repeated addition. I would add 2 1/4 plus 2 1/4 plus 2 1/4. You're putting this on your paper along with me. Plus 2 1/4. And double check. 1, 2. All right, and now I'm ready to add. I'm going to start by adding my whole numbers. 2, 4, 6, 8, 10, 12. And now my fractions. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. And we know that 12 6/4 is just equal to 13 2/4, or you could be saying 13 1/2. So we got the exact same thing, whether we drew it out with a model or we used repeated addition. Let's try one more way. Let's actually try multiplying. I know that our original number sentence that matched the story was 6 times 2 1/4. So in order to multiply this, I'm going to use some partial products. So if I'm doing, put some space here, I want to do 6 times 2 1/4. So I know that I need to multiply my 6 not only by my 2, but also by my 1/4. I need to multiply it out, just like if we had 6 times 24, I would have to multiply 6 times 20 and also 6 times 4. So the first thing I'm going to do is 6 times 2. I'm just going to write down my partial products. 6 times 2, I know that one is 12. And then I need to multiply 6 times 1/4. And luckily, I know how to multiply fractions. I know first I multiply the numerators, then I multiply the denominators. I know that when I have a whole number, it's like having a denominator of 1. Exactly right. And so as I think about how I would multiply this, I'm just going to multiply my numerators. 6 times 1 is 6. 1 times 4 is 4. And so I get 6/4, which I know is the same as 1 and 2/4. And I just need to add in my partial products. So 12 plus 1 and 2/4 equals 13 and 2/4. Exactly the same answer I got when I solved it using repeated addition and when I solved it by making a model. It was just a little bit more efficient when I did my partial products to multiply 6 times 2 and then 6 times 1/4, and then I added those up together. All right, we're rocking and rolling. Let's take a look at another example. All right, one thing that you may or may not know about middle school next year is that you have the option of signing up for band. And so next year, as you guys get to the middle school, half of the scholars at VCP sign up for band. Now, of those scholars who sign up for band, so we have half of all of you sign up for band. Of those scholars, 1/4 of those scholars in band decide to play the drums. Everyone can't play the drums. You need a bunch of different instruments in band. So 1/4 of you decide to play the drums. Some of you will play the saxophone. Some of you will play the trumpet. Some of you will play the trombone. So many instruments to choose from. But what we want to know is if half of all scholars signed up for band and 1/4 of the scholars in band decided to play the drums, what fraction of scholars in the band will play the drums? You are going to try this one on your own, and then we'll talk through some strategies. The first thing I want you to ask yourself is more or less than half of all the scholars going to be playing the drums? This one's a little bit tricky. I want to see what you can do. I'm going to give you 1.5 minutes to work on it on your own, and then we'll check in and see what you got. Go ahead. Challenge yourself to also write a number sentence that matches this story. All right, let's see what we came up with. What is the number sentence that matches this story? It is a multiplication problem. Because if we think about half of the scholars signing up for band, and of that half, 1/4 of the scholars, when we see those clue words of, if we have a fraction of another fraction, that's just a really, really great clue that it is a multiplication problem. We're not dividing anything. We're not splitting things up. We're not passing things out. This is actually a multiplication problem. So if we were to write the number sentence that matches our work, or the number sentence that matches the story, we would write half of the scholars sign up for band, and of that half, 1/4 of them are going to play the drums. 1/4 of 1/2 is the same as 1/4 times 1/2, or 1/2 times 1/4. Let's draw this out though and make sure we understand why this is a multiplication problem. So first I want to start by thinking about the whole school. So I'm just going to draw this one box. This is going to represent all the VCP scholars, all of you who are going to 6th grade to your brand new middle school next year. Now, all of the scholars don't join the band. How many of the scholars join the band? That's right, only half of them. So I'm just going to split this in half. And I'm going to label this half as band. Now, the other half chooses to do something else. So maybe they decide to do orchestra, or they decide to do choir where they're singing, or they decide to do sports, but they're not in the band. Now, of the scholars in the band, 1/4 of them are going to play the drums. So I'm going to take the band and I'm going to split the band into fourths. I don't want to split these scholars into fourths because if you're on the swim team instead of doing band, you're not going to be playing the drums. It just wouldn't make sense. Your drums would get all wet. You can't swim very fast if you're carrying drums. So I don't want to think about the kids who aren't in band. I just want to take the band and split my band into fourths. All right, now I split my band into fourths, and 1/4 of the band is going to play the drums. So I'm just going to label that as drums. Make sure you have this model on your paper along with me. This is going to be really helpful as we're solving these multiplication problems. So all of these scholars are in the band, half of you guys, and then of the scholars in the band, 1/4 of you are playing the drums. Your parents will be thrilled if you come home on the first day of school and say, I signed up to play the drums. Here's my drum kit. And don't worry, I'll be practicing late at night. Parents love that. Now, I need to figure out what fraction of all of the scholars are playing the drums. So I can't just say it's 1/4 because I have to remember all these scholars over here who aren't actually in band. And so this is where I need to figure out, sometimes I like to draw a dotted line so I can really see how many pieces there are. I'm just looking for this piece right here. And I want to know, of all the scholars at Vista College Prep, I should say what fraction of scholars at VCP play the drums. So if I'm looking at this fraction of the whole school, I can figure out, well, this is one piece out of, let me just double check, 1, 2, 3, 4, 5, 6, 7, 8. It's 1 out of 8 pieces. It's not just 1 out of 4. 1/4 of kids who are in the band play the drums, but 1/8 out of all of the kids are actually playing the drums. So I can always draw a model. But let's also take a look at how some scholars solve this using what we know what the standard algorithm is for multiplying fractions. So I know my number sentence was 1/2 times 1/4 because we were finding 1/4 of that 1/2. In order to multiply fractions, I know I do not need to find a common denominator, which is kind of great news. I just need to first multiply my numerators. So I'm going to multiply across my numerators. I have 1 times 1 is 1. And then the next thing I need to do is I need to multiply my denominators. So I just multiply straight across. 2 times 4 is 8. We got the same answer either way, both with our model where we showed the scholars who are actually playing the drums and with our standard algorithm. I knew this was a multiplication problem because of these clue words of. When it's asking me for a fraction of another fraction, it's asking me to multiply. All right, one more to go. All right, we have a final story about Sally and Jessica who are packing up their backpacks and they are pretty full. So Sally has a backpack that is 4/5 full. She can barely fit anything else in there. Jessica's backpack is only 2/3 as full as Sally's. And we want to know, how full is Jessica's backpack? All right, I'm going to challenge you to see if you can try this one on your own. So find some room on your scrap paper. See if you can write the number sentence that matches this problem, think about what we are doing. Are we adding these fractions? Are we subtracting? Are we multiplying? Are we dividing? And then pick a strategy you want to use to solve it. All right, let's go ahead and check in about the number sentence that you use to match your work. What is this problem asking you to do? And if you are really stuck and you're not sure about if it's multiplying or dividing or adding or subtracting, you can also start by drawing a model, and that can often help you figure out, okay, am I dividing something up or am I actually multiplying a fraction by a fraction? So any thoughts on what this problem is asking us? Is this asking us to add? Well, no, it's not saying how full are their two backpacks all together. Is it asking us to subtract? No, it's not saying how much more full is Sally's backpack than Jessica's. Is it asking us to divide? It's not asking us to divide. We're not splitting anything up or passing anything out. So we're not dividing. This is a multiplication problem. And sometimes these fraction problems can be a little tricky to figure out, am I supposed to be multiplying? But if I think about Sally's backpack is 4/5 full, and Jessica's backpack is 2/3 as full as Sally's, or it has 2/3 the amount of stuff as Sally's. This is a multiplication problem. So let's go ahead and write out our equation that matches the story. And now we have a couple different ways of solving this. If you feel confident using the standard algorithm to multiply fractions, that's great. You can go ahead and solve it that way. If not, you can draw yourself a model and then double check. I do want everyone to be able to do both strategies. So challenge yourself to see, can you use the standard algorithm? And then we'll draw out a model to make sure it works. So challenge yourself, can you use the standard algorithm by multiplying the numerators and then multiplying the denominators? And you would get an answer that Jessica's backpack is 8/15 full. Let's draw it out to make sure we get the same answer. So I'm going to start by showing how full Sally's backpack is. If this one hole represents Sally's backpack, her backpack is 4/5 of the way full. I don't want to shade too dark because I know I'm going to be splitting this into more pieces, but just to do a really light shade to show how full Sally's backpack is. So Sally's backpack is 4/5 of the way full. Now Jessica's backpack is only 2/3 as full as Sally's. So I'm not even going to consider this piece right here, kind of like the kids that weren't in band. If you chose to do the swim team instead of the band, I don't even want to think about you when I'm thinking about how many kids in the band are playing the drums. So I'm not even going to be thinking about this piece right here. But I know Jessica's backpack is 2/3 as full as Sally's backpack, which is this 4/5 right here. So I'm going to split my 4/5. I need to split it into thirds. And Jessica's backpack is 2/3 of these full. So I'm going to use a little bit of a darker shade to shade the 2/3 full. That is Jessica's backpack. I didn't even consider this piece right here because that's not even part of Sally's backpack. That's like those kids that weren't in the band. Okay, so now I want to figure out, well, how full is Jessica's backpack? It's this amount that I shaded in darkness. Well, I can figure that out by just counting the pieces that are shaded in really dark. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now here's where I don't want to get tricked. I don't just want to say it's 8 out of 12, 8, 9, 10, 11, 12, because just like in our last example, we didn't want to know just of the fraction of the kids who were in the band that were playing the drums. I want to know of the whole thing. So how full, if we have Jessica's backpack, how full of her whole backpack is it? How much of the backpack is taken up? So I need to remember to count all of the pieces. Sometimes I like to do dotted lines just to show where those pieces would be. So I can see that the whole thing would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces all together. So Jessica's backpack is 8/15 full. So she still has some room to fit some stuff in there. Sally's is pretty full. I got the same answer whether I multiplied using the standard algorithm by multiplying my numerators and then multiplying my denominators as I did when I drew a model. I want to make sure we know how to do both of these strategies. This can also help us make sure we know, are we multiplying? Are we dividing? Are we adding? Are we doing something else? So when we are multiplying fractions, two big strategies we talked about today. Tomorrow we're going to talk about a couple more. One thing you can always do is you can draw a model. For example, if I was multiplying 2/5 by 3/4, I could draw my whole. I know I'm starting with less than a whole because I'm starting with 2/5. I could split my whole into fifths. That's what's being shown here in these blue lines. And I'm just looking at 2 of the fifths. But then of those 2/5, I just want to show 3/4 of them. So I'm taking my 2/5 and splitting them into fourths and then shading in 1, 2, 3/4 of that. Then I need to figure out, well, how much is shaded in this dark color? Well, it's a total of 1, 2, 3, 4, 5, 6 pieces. But it's not just 6 out of 8 because I want to know how much out of the whole thing. So this is where I like to draw my little dotted line and realize that this is actually 6 out of 20 pieces of the whole. So that's how I would get to my answer of 6/20. Another thing we can do is we can use the standard algorithm to multiply our fractions. And so when we use the standard algorithm, first we multiply the numerators. So first I just multiply across 2 times 3, and that's 6. And the second thing I do is I multiply the denominators. So here I would multiply 5 times 4, which gives me 20. You may be thinking it seems a little bit more efficient or a little faster to use the standard algorithm, and that's great. We have spent a lot of time this year drawing models. As long as you understand how the models work, you are more than welcome to just use the standard algorithm. It's great once you understand how something works and you have a really nice, efficient way of solving it. Tomorrow, we're going to go more into how we could use our partial products once we get some more mixed numbers. All right, we're ready for our final bit of practice, and then you are on your own to do your independent practice. 4 questions to do with me right now just to check in and make sure you are super confident. You can go ahead and do all 4, thinking about which strategy you like to use to do your multiplication of fractions. As a reminder, and this will be posted in your Google Classroom as well, you can draw a model. You can use the standard algorithm by multiplying the numerators and multiplying the denominators. Don't get tricked if you have a whole number. Think about what the denominator really is in that whole number. Go ahead and write down your first problem and get to work solving. We'll check in a couple of minutes. If you solve them all using the standard algorithm, I do challenge you to go back and try drawing a model just to make sure you can prove where all your answers are coming from. All right, 30 more seconds and we'll check in. All right, let's take a look at our problems. Let's start with problem number 1, 4/5 times 1/3. You can have a pen or a crayon or a marker, anything you want out to check your work. First, I solved this using the standard algorithm. I multiplied my numerators, 4 times 1 is 4, and then I multiplied my denominators. 5 times 3 was 15. And we got to an answer of 4/15. If you also got to an answer of 4/15, go ahead and give yourself a check. If you did not draw a model, go ahead and draw one now. I drew my hole and then shaded in 4/5. So right here I have 1/5, 2/5, 3/5, 4/5. But then I only wanted 1/3 of that. And so I had to take my 4/5 and split it into thirds. I shaded those in a little bit darker. It's these pieces right here. I can see I had 4 of them shaded in, and there would have been a total of 15 pieces in the entire whole. So I got to the same answer of 4/15. Question number 2. All right, here I had a whole number, 3 times 2/8. I know that when I'm multiplying by a whole number, the denominator is just 1. You can write it in if you like. If you don't need to, that's great too. So when I multiply across, multiplying my numerators, I got 3 times 2 is 6. And when I multiplied my denominators, 1 times 8 is 8. I can also show that by drawing out my 3 holes, 1, 2, 3. And each one of them, I have 2/8 shaded, and then I can just count my 8s. 2, 4, 6 eighths shaded. If you got to an answer of 6/8 or 3/4 if you reduced it, go ahead and give yourself a check. Nice work. For question number 3, again, we had a whole number, so we looked at 3/10 times 4. I could just use my standard algorithm and multiply 3 times 4 is 12. 10 times, I know my denominator here is 1. 10 times 1 is 10. I don't want to leave my fraction as 12/10, so I did convert it to 1 and 2/10. I can show that with my picture by drawing out my 4 holes. splitting each one into tenths and shading in 3/10 of each whole. When I went back to count my pieces, I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tenths, which I could reduce to 1 and 2 tenths. If you got 1 and 2 tenths, go ahead and give yourself a check. And finally, for our last problem, it was a word problem, telling you a little bit about my trash can. Clearly, it is trash day soon. I need to take those out. The trash can in my kitchen was 4/6 full. The trash can in my bathroom is just 1/4 as full as my kitchen trash. And I wanted to know, how full is my bathroom trash? Well, it's asking for a fraction of another fraction. This reminds me of the backpack problem. I know it's asking me to multiply. So first I tried it using my standard algorithm, 4/6 times 1/4 when I multiplied my numerators and then multiplied my denominators. I got to an answer of 4/24. You could have also reduced that to 1/6, but 4/24 would be correct. If you have that, go ahead and give yourself a check. And if we think about what this would look like as a model, I would draw out my whole. I first split it into sixths and lightly shaded in 4/6. That's this piece right here. That's how full my kitchen trash is. And then my bathroom trash was 1/4 as full of the kitchen trash. So I don't want to consider the amount of trash that isn't in my kitchen trash. So I split this into fourths. I darkly shaded in 1/4. So I knew I had a total of 1, 2, 3, 4 pieces out of what would have been 24 pieces all together. All right, scholars, that is it for today. Today, we talked about some different ways of multiplying fractions. Remember that when you are multiplying fractions, 2 great strategies to use are either drawing a model or using the standard algorithm by multiplying the numerators and then multiplying the denominators. You are also welcome to use partial products. We're going to get into that more tomorrow when we start to see some more mixed numbers. Best of luck on your independent practice today. We'll see some of you tomorrow morning for reteach, and please remember to come to office hours today if you have any questions.